So we're starting week 5, and we had done all of shapeshifting. For mad science, we had talked about fractions in lots of ways. We had almost finished percentages, but not quite. We did that. I have a certain percent of a number. We did a percent change where I have an old and a new value, and I'm looking for the percent. So this one is I have the percentage. This one I'm looking for the percentage. We talked about the 1+ trick to make things grow by a certain percent. And now we're doing simple interest. We had started simple interest just by saying it's the same as a percent change problem. But then when we had multiple loans, we couldn't use the 1+ trick anymore. Multiple year loans, we couldn't use the 1+ trick anymore. We just had to do it in parts. And then I mentioned at the very end of last class, there's a formula. So let's do this formula, and that'll be a review. And then we'll talk again about the dangers of this formula, which I only barely talked about. Oh, but actually, before I do this, do we have homework questions before I start the new stuff?
I do.
You do? Okay. So
yeah, we do.
So actually, when you were disconnected from us, I was talking about the percentages, math science.
Okay, random or turn in?
It was actually the turn in. I had gotten number 8, 9, and 10 done, which all happen to have is about simple interest. So maybe if we could just go over simple interest again.
Okay, that's good. I'll keep this open and we'll use these as example problems. Any other homework questions before we talk about simple interest? No. Okay, well then we will talk about simple interest. Okay, I need to get out my little pad to write on. Okay, see how this works. Different table, different handwriting. So, since I don't want to do your turn-in homeworks for you, I'm going to change the numbers slightly. Okay, let's find the simple interest of a 2-year loan at 14% simple interest rate. So there was a part A of the 1 year. So we're looking for 14% of 6,000. So we remembered that of means multiply. Should I keep writing Riplop, or are we done with me writing Riplop on the board because you've seen that so many dozens and hundreds of times? I'm not hearing either way. I'll write it one more time and we'll see next time I ask what people say. So left out of percent. So 0.14 times 6,000, 840.
I like seeing the Riplop because repeating stuff helps me.
Okay, then I will keep doing it. So that's the 1 year answer. Then we have actual number of years. Until this point, the fact that it's been a 2-year loan hasn't been part of my thinking. Simple interest is designed to work for 1 year, so I've just ignored the time frame until that. But now I have to go back and say that 840 is every year. So since we have 2 years, then I'm going to have to multiply it by 2. Okay, everyone happy with what's on the board so far?
Yeah.
So this is actually the not as a formula. This is just treating it like any other percent of problem. On the next slide, let's actually do this as a formula. Oops, and I have to grab my problem too, don't I? I know what I'm going to do. I'm going to grab it that way. So rather than think about step A and step B in the red subheadings, I'm just going to use the formula. So the interest is going to be that 6,000 times the rate. So in this problem, I would write my Riplop over here if I'm doing it that way. And then times the years. And I would still get my same answer, whatever it was, 1680. Yeah. So that seems a lot nicer, right? That's a much shorter, cleaner amount of stuff on the board than we had last time. The only disadvantage to this is that there's a danger of doing it wrong. And there isn't much danger the way the formula is written now. It reminds us it's simple interest. You're not going to try and use this with a compound interest problem. There aren't any in Math 20, but just in general. And it's reminding you that it's an annual interest rate. And it's reminding you that you're multiplying by how many years, because the rest of it is just a per year amount. So the only danger comes when people write it in the more traditional short way. Because now those reminders aren't there. It's just I equals P times R times T for principal and rate and time. So if you are doing this formula, what I would highly recommend is listing out all your variables before you plug things in, because this is where mistakes will happen. In this case, the interest is what we're solving for. The principal was 6,000. The rate was 14%. And the time was 2 years. And I would also write per year so that we have years and years, the 2 time units match. That will become very important when things get a little more complicated in the next few minutes. Now when I plug things in, it's exactly the same as before. And we're happy. If you wanted the riplop, you could do that. So this is in between. It's more writing than this, but I wrote the formula in a shorter way. Am I making a big deal out of nothing? So let's check it with a trickier problem and see what way works for you. So I'm going back and doing all three ways, as a formula, or not as a formula, as the longer formula, and as the letters only formula. But let's pick instead number 10. I need to shrink it a little to grab it. Okay. So 1, 2, and 3. So first we'll do it not as a formula. So what did I call it before? 1 year's answer. I want 5.2, oops. I forgot to change the numbers. I'm doing your homework for you. Oh well. Okay. Happy with my first step? So how long is my actual thing? 90 days. So I have to take my old answer. This is per year. And I'm going to multiply it by something. I'm not going to multiply it by 90. That would be if it was a 90-year loan. What am I going to multiply it by instead?
3.
3, not 3. That would be a 3-year loan.
What about 3 over 12?
3 over 12. That would be 3 months out of 12 months. That's about 90 days. I wouldn't mark that wrong. But since it's actually in days, then I think I want my denominator to actually be in days.
So that'd be 90 over 365.
Yeah. Very slight difference. Hopefully we're not having our loan with the mafia that would really care and send someone after us, but we'll do it the right way. Okay, so why do we have this fraction? Because this is an amount per year. And this is how much 90 days is as a fraction of a year. In my calculator, I'm going to write the 341, actually I'm not going to use the dollar sign on the calculator. I'm going to multiply by 90 and then divide it by 365 because fraction bars are like division. So 341.25 times 90 divided by 365 gives me 84.14. Everyone get the same answer? I didn't push things wrong on the calculator.
Just to clarify, like, instead of doing the 90 divided by 365, if you multiplied it times the fraction one, that would do the same, right?
Your fraction button should be the same.
Okay, yeah, I thought I got the same answer on this exact question doing it that way. I just, I didn't actually do it 90 divided by 365, like write it out that way. So
Yeah, if your calculator has a fraction button, good for you. But if I remember right, when I asked at the beginning of the term which calculators did, very few people had those fancy calculators. So
I think we talked about that. I had a little of an issue actually finding the one that you had suggested, and I got this one, and it does all the same stuff. But
okay, anyone not get this answer? Need help? So this is a lot of writing, but it kind of breaks us down into the steps. Whoops, and I'm not spelling the word answer right. That's embarrassing. Breaks it down into the steps of what are we doing. Simple interest is designed to work for 1 year, but we don't have a year, so we have to fudge it at the end. Okay, so now let's do the same thing with the long formula. Whoops, that's the short style formula. I didn't go back 2 slides. There we are, longer. So in this formula, we've written out the words to help us remember what's happening. So the principal is our 6,500. The interest rate, we're going to ripple up here. If you're not writing it, then in your head, when you take the 5.25 and put it in the formula, then make it a decimal. And again, we have 90 days. So I'm going to make that 90 over 365. And what was my answer? 84.14. So we're writing a whole lot less because we're not reminding ourselves on the page of what's happening. Hopefully we're still thinking in our heads. First, I'm finding a 1 year's answer. That's this part. And then I'm adjusting it for how many years we actually have. In this case, less than 1. So if this works for you, great. For some people, remembering to do that or the RIPLOP is a pitfall. They would rather write it all out so that they don't make mistakes. For other people, I can remember the RIPLOP. I can remember to take days and change it into years. So efficiency is workable for me. Questions on that slide?
So if you did it with months, it would just be the 60 over the 365.
With months. If you were to take 90 days and make months, then
It's like 2 months loan, so it's just you're just changing it then to 60 days instead of 90.
You can't change the days. 90 days is about 3 months. So
I
if
know.
you,
I'm just saying. I
if you
had
wanted to write that as 3 over 12, that would be about the same. If you're thinking months.
right. I just don't understand why I have such a hard time. Like a year loan. It's
Mhm.
when it break it down to smaller, like 1 month, 2 months. But I think I got it.
Yeah. So if you wanted to write the 90 over 365 as 3 months out of 12 months, you could do that instead.
Okay.
Close enough. You'd only be off by a few cents. I wouldn't care. Okay, so here we have the shorter style formula. And I would encourage you not to jump to writing very little. So you could go directly to plugging things in. If you've done lots of these as homework, there's nothing wrong with treating this exactly the same as the other formula. But very few Math 20 students will do this on the final exam and not mess up. It's too much to remember that T actually means years, not time. And somebody's going to put just a 90 here instead of a 90 over 365. Or it's too much to remember that R is the rate needs RIPLOP, and people are going to put a 5.25 here instead of the right decimal or something like that. So if you're using the shorter fraction, a shorter formula, then I very much encourage you to list out all the things first, which is a good practice for how to treat formulas anyway. That way you're not trying to do too much in your head. And then you'll write the same things as before, but not make careless mistakes as we go. And whatever that was, 84.14. So pick which one of the 3 styles you like. Maybe you have to do a little bit of homework practice to see which one is really best for you. I'm going to go back up to the random problems, and I think these get a little trickier. No, not for Math 20. Okay, I am misremembering, so that's as hard as it gets for you. Should we do this random one I just brought up anyway? Yes, okay. Which style should I do? The not as a formula, the formula with words in it, or the formula with just letters?
If you wouldn't mind just going over them all, just so like we can get down all the different styles. Like I do the one, but seeing the other ways, it has been a little helpful. So
Okay, if they're all helpful, it's a good use of time. Try and write it a little less wordy so I can fit more on the screen.
Somebody cleaning the room?
It sounds very noisy. I can mute everybody. How do I do that quickly? Mute everybody. Okay, unmute yourself if you want, but that'll stop the noise. So that's what we have each year. Now it seems too quiet with everyone muted. Anyway. Then our time frame. So 122 days. What am I going to multiply by?
$122.
Divided by 365.
If you're someone that really loves months, and I sort of estimate this with months, how many months over 12 would I do?
4.
4, right? So not quite as accurate, but good enough. But I will stay with what's kind of most professional.
So just a real quick question for clarification, like not about this, but when we're writing out our work for the like the assignments where you have to show it, when we're doing like the percentage and stuff, do you care if we actually write the 0 on like the front side of that? Like when we're moving it over, like if I was just point 0.15,
That's me as a lecturing person. If we were just an office hours or study session, I might not write it either.
Okay, so like when we're writing it out, we don't have to do that then, like, you know, if it's clear that it's 0.15, for example?
Yep.
Okay, cool, cool.
Now, when I'm lecturing, this 0 partly slows me down so that you have time to keep up. Partly helps make this decimal point and this multiplication dot look different. And partly helps me narrate as 0.15 just to give your ear an extra heads up a decimal is coming compared to if I just say 0.15.
Okay, cool.
So it's politeness of lecturing. It's not right or wrong. Oops, it's not a straight line. I'm doing the old problem, 4,600. So if I'm doing the formula, then I should RIPLOP the 15%. Maybe I will think about doing it up here. Maybe it will only be in my head. And again, I have to change this to 122 over 365. So a lot more on the board on the left. This is doing it sort of efficiently if I'm up for it. And if I'm not, that's okay. Just write more out so I don't make careless mistakes. Why am I putting the I equals solve for? Because in theory, if you were in Math 25, there would be problems where they give you the interest and you're trying to solve the principal or the rate or the time. So it's not always true I'm solving for the I. So I'm just confirming that, yes, that's what I'm doing. And again, this style says, I'm not going to really RIPLOP in the middle of my work, nor am I going to RIPLOP as I read the problem. I'm going to keep myself organized before I plug things in so that nothing messes me up. Because for almost any type of math problem with a formula, the hard part is what to plug in. The actual plugging things in and finding the answers, that's just the calculator doing its work. Questions on any of that? No questions. Okay, well, let's see where we are. So there's the reminders about that. There's more example problems, but we did ours, and we're on to measurement. So we just had a homework question on percentages. So percentages doesn't have a due date yet. Fractions wasn't due before, right? Did fractions have a due date?
Today, wasn't fractions due today?
Was fractions? It might have been. Yes, it was. I see. Okay, so this is due today. Get it in by the end of the day. Percentages has no due date, probably a week from today, because maybe we'll have no questions on Wednesday. On to measurement. So actually, before we do that, remember we're in mad science. So we are now putting different numbers together. That's our theme for here. So we put fractions together. We had percentages with other numbers at the same time. And now we're doing measurement with lots of numbers at the same time. If you're in the green free book, then here's the pages we're on. If you're in the green book that's a physical book with zebras, we're in 8.1 and 8.5. And this reminds me of a tangent. So it is still true that the only kind of end of subtopic video I've made was the one I had made for rounding. And the reason I haven't made more was just sort of a guideline for good pedagogy, that I should only ask you to do things if either I am going to assess how you've done them, or you're going to report that yes, you've done them. If no one's going to check how it went, then why am I bothering to ask you to do it? Is it really that important? So a couple of people said the idea of an end of subtopic video, how rounding connects with our other issues, made sense when I talked to them, but nobody cared enough to actually send me an email without me being on the phone with them anyway. So that's why I made the representational fluency thing, because this was why you actually care about rounding and what hundredths means as place value and things like that. So this is something that I can give you a star for. It is something you do instead of something you watch. It just makes much more sense as something to spend my time designing and your time putting in your brain. So I can certainly make more of these end of subsection videos if it's helping people, but until people fuss and say they want to, I will just keep making things that you actually do instead of just watch as more options for stars. The textbook is sort of an exception, that I'm not asking you to do the textbook, right? We tend not to get textbook problems during the class, although we certainly could start the class with textbook problems. The textbook is something that mostly you are asking yourself to do. You're sitting down to try the random problems, you're sitting down to try the turn-in problems, and something's not working. So you say, oh, I need to see how the textbook explains this also, and see their example problems and their good videos and do some of their homework at the end of the section. So that's why we have at the homework what are the good homework problems to do in your textbook. So this isn't something really I'm asking you to do. This is something that hopefully you are asking yourself to do when you say, okay, yeah, a few of these problems are helping me. Maybe I should do all of these. Maybe I don't need all of them, but whatever. Anyway, okay, end of tangent about textbook pages when I see them. So we had one-step conversions, and they were okay, but not great. They were kind of awkward, and they didn't work all the time. So this is the better thing to do. And if you don't remember the one-step conversions, then let me just show you them real quick. So they were these rules here. Put them on our board. So the idea was that if you are very good at converting from one measurement unit to another, because you do it often, you're a carpenter who uses feet and inches, you're a baker who uses tablespoons and cups or something like that, then these are nice things to have in your brain. When you're starting from a measurement unit like feet, that's a multiple of a smaller thing, then you're going to multiply. You know it's a 12, so we'll multiply by the 12 to get from feet to inches. When you're starting with a smaller thing, like inches, that are a factor of the bigger unit, like feet, then you divide. If I'm going from inches to feet, I'll divide by the 12. And if you're used to this, this is nice. It's reassuring to know that, yes, I know just instinctively to multiply or divide by 12 because I do lots of carpentry, and here's a good rule that shows me I'm smart. Unfortunately, this is just a little awkward if you don't do it often. You have to remember two different things and when to use them, and there's just sort of a lot of parts here. So what we're doing now is one process that always works. It is completely fail-safe. Unfortunately, the penalty we pay for that is we have to write a little more. So just like the writing a little more so that things are more fail-safe, now what's going to happen with measurement? Everyone okay with my prologue? Okay. So here's the steps of a process called unit analysis, and if I were to read them out loud, it would just be terrible. So I'm going to do them in action. And I'm going to do them first with a ridiculously easy problem. And then I'm going to do them again with a harder problem. And I'm telling you that in advance because otherwise someone will fuss at me when I do the easy problem and say, this is too easy. Why are you doing this stupid long process for something that's so easy? So the process you will appreciate on the next slide. For now, it is just an annoyance. So my problem will be, how about 5.7 inches is how many feet? So using our previous lesson, are we going to multiply by 12 or divide by 12 when going from inches to feet?
Divide.
Divide. So this whole thing is just going to turn out to be divide by 12. So that's okay. This is too much work for just dividing by 12, but bear with me. So my first step is to write the given measurement as a fraction. So they gave me 5.7. So I'm going to write 5.7. It's not a fraction. How do I make something into a fraction when it's not?
Put it over itself, right?
No, that would make it equal to 1. You're very close.
Put it over 1.
Put it over 1.
Yeah.
Some measurements already are fractions. If it was like 30 miles an hour, then there's the 30 miles on the top and the 1 hour on the bottom. But if it's not already a fraction, then I put it over 1. Okay, my next step is to write some empty rates without numbers. I want to get out of inches and into feet. So I'm going to treat the numbers as if they were factors and canceling. I have an inches on the top, so I need an inches on the bottom, so they will cancel. What am I going to go from inches into? Can I go directly from inches to feet? Sure, I know how to do that. Third, I'm going to put the numbers in, and this is just so I don't have to erase as much if I made a mistake. But I know that 1 foot is 12 inches. Fourth, I'm going to multiply. How do I multiply fractions? I multiply across the top and bottom separately. The inches have canceled out. So in the top, the only word left is feet. And in the bottom, the inches has canceled out. There's no words at all. So I just keep the words as I'm multiplying. And last, I'm going to simplify. How do I simplify any fraction into a decimal? I do top divided by bottom. You've seen that for turning fractions to decimals. You've seen that in other cases too. So 5.7 divided by 12 is about 0.46. Okay, everyone happy with my colorful rainbow of steps?
I got 0.47 feet, actually closer to 0.48.
0.4, 5.7. Oh, yep, I just typed something wrong on the calculator. Not sure what. So it's that, and it's not rounding. I wonder what I typed. Okay. Thank you, Rob.
You're welcome.
Ready for the harder one? So this was a terribly long process to tell us divide by 12. That was kind of ridiculous. But on the other hand, we couldn't really make a mistake. Putting a number over 1 is really easy. Knowing that I want inches on the bottom because I had inches on the top and I want them to cancel. Knowing I'm going from inches to feet. Putting my conversion rate in, 12 inches is 1 foot. Multiplying across the top, multiplying across the bottom, top divided by bottom. Right, so it guides me through everything. That's the reason we have this process. So let's do one from the homework. I'm not sure why it says round your answer. I don't think we need that anymore. I should get rid of that. Pasting, paste, there you go. I'm gonna make a note to myself, remove. Okay. So my problem, rewriting it, is 16 yards in 3 minutes is how many miles per hour? I'm used to thinking of speeds in miles an hour. Like I drive my car in miles an hour, I go jogging or biking in miles an hour. So somebody measured a snail and they measured 16 yards in 3 minutes, and it makes sense that they might measure a snail with yards and minutes, but I'm not having any good mental sense of how fast that really was. So let's switch it to the kind of speeds we're used to thinking about.
That's a fast snail.
That's why it's Stalwart the Wonder Snail. So when the random numbers do things, then I don't have to worry. There's another problem with dinosaur food for the same reason. Okay, so blue first. Write our given measurement as a fraction. It already is 16 yards, 3 minutes. Green, write some empty rates without numbers. So I want to get out of yards. Am I going to put the next yards in the top or in the bottom?
Bottom.
Bottom. Why in the bottom?
Because you're canceling them out.
I'm canceling. I have to cancel with something in the top and something in the bottom. Can I change yards into miles directly? Do I know that one? Maybe you do. I'm going to pretend I don't. I can change yards into feet. And I happen to know that 3 feet is a yard. Okay, I don't want feet, I want miles. So where do I write the word feet, top or bottom?
Bottom.
Bottom, because I have one in the top. So now it's going to cancel. Can I go from feet to miles? Yes, I know that one. If you don't, then put it in your notes. 1 mile is 5,280 feet. Okay, I'm not done. I got miles on top like I wanted. Yay! But on the bottom, I want hours and I still have minutes. So I need another fraction. Where am I going to put my hours? Where am I going to put my minutes?
Minutes on the bottom?
Minutes on the bottom. I can't cancel if I do that. Don't write this. If I do, then I have
Oh,
minutes on the
miles,
bottom.
sorry.
Minutes on the
Yeah.
bottom. Yeah.
Hours on the bottom.
So minutes has to go on the top. Then it will cancel. Put hours on the bottom. Can I do that with one fraction? Sure. 1 hour is 60 minutes. I'm glad that mistake was made because people will make it at homework time. So the fact that you just recognize it and erase and keep going, I wanted everyone to see that. Why do I have hash marks that always look different? A single slash, a double slash, a squiggly slash. That's just me being extra nice so that when I'm looking back at this in week 10 and studying for my test, I can say, what did I do? Ah, this canceled with that and that canceled with that. Or if I'm working with someone and comparing my homework to theirs and holding my paper up to the webcam and saying, look, here's what I did, then they can see which things canceled. So if you always make slash marks that are the same, that's fine. No one's going to mark you wrong. I'm just being extra polite and making all of my cancels look different from each other. Okay, multiply. I multiply across the top, 16 times 3 times 1 times 60. If you wanted to write that out, you can. Whoops, I did plus, that's not going to work. So 2,880. What words are left in the top? Just the miles. On the bottom, 3 times 1 times 5,280 times 1. What words are left on the bottom? Just the hour. I'm going to make that 40 look more like a 40 and less like a 90. Everyone okay that I'm not writing out the multiplication itself?
Yeah.
Yeah.
And then lastly, I think I've switched colors from last time. Oh well. Simplify the fraction. Answer is top divided by bottom. I see what happened. I need to use my secret calculator reset button. Okay. So I'm getting about 0.18.
Yeah.
So should I write it with 2 decimal points? Probably not. I would be happy if you wrote that, but I think I'm going to actually round it to 0.2. Do I think I actually know this to the 100th of a mile per hour? I think that's exaggerating my accuracy. And that's as hard as these get. We should do lots more of them. This one was too easy. I didn't need all these steps to just divide by 12. This one, you can kind of see why if I tried to fudge it bit by bit using the one-step conversions again and again, there's a good chance that I would make a mistake somewhere along the line, especially in a test pressure situation. I know that from yards to feet, there's a 3, and from feet to miles, there's a 5,280, and from minutes to hours, there's a 60. But trying to put all that together without making any mistake, if I'm trying to just use our old process, I'm asking for trouble. If I'm not someone that's just very good at this because I have lots of practice, it's too easy to multiply when you should divide or divide when you should multiply. Whereas this process, I had to write a lot. But again, I never had to really make any choices. It told me what to do every step of the way, so that I never really had to decide what to do. I just followed the procedure. And as long as I don't have to make choices, then I can't make the wrong choice. Ready to try your own, and then I'll do it on the board after a delay?
Sure.
Okay. So coffee lover Chuck drinks 14 cups of coffee every day. And we want to write it as so many gallons per year. That's a lot of coffee, Chuck. Okay. Oh, by the way, one last thing on this one. Notice how important it was that minutes is MIN and miles is just MI.
That is what actually messed me up for. I was just looking up, glancing, and saw the MI and MIN, and that
Yeah.
I put the wrong ones.
Some of these problems have meters, which are just M. So if you are someone who is sloppy with your labels, then be good about that. I'll even make a little note down here. So M is meters. MI is miles. And MIN is minutes. So for the sake of everyone who's trying to grade your work, don't make your own conventions. Use the same one that everyone else uses. Okay, but none of that in here. No M's in this problem. And I'm not sure which slide I should have on the screen. Do you want me to go back and show you the other one with all the steps? Is anyone going to fuss if I go back and show you the one with all the steps?
No.
No.
At all.
Everyone has the 14 cups per day into gallons per year. Just a reminder, if you ever want to look at a slide other than the one I'm looking at, you can look at the Jamboard too in a different tab on your browser. Oh, let me go back. Announcement I should have done. So besides the Jamboard links, this is sort of like the external links, right? Things not on the website itself. So besides the Jamboard links and the LCC and MyLane links I give you, here's those new links for the tutors. I sent out an email saying that now we have tutor in Moodle. So if I click on this, then it will ask me to log into Moodle. And when I do that, then it will say there's no questions yet, but any of you can go here. Again, Math 20 forum questions, and say, wonderful Greg Tutor, can you do shape-shifting turn-in problem number 3 or something, and have the tutors help you with your homework or whatever. So that's up here if you've lost the email where I shared that in email. Okay, back to this. Are we ready for me to start it?
Yeah.
Yes, okay. I'm gonna try and be consistent with my coloring. So write it as a fraction. It is a fraction. Make our plan. So doesn't matter. Should I change the cups first or the day first?
I did the cups.
You did the cups. So cups into gallons, we know that one. And if I've done that, I'm done with cups. So I just need to do the days. So I have my plan. That gets me to gallons per year. That's what I want. I'm happy. I stop with my plan. Step 3, fill in my numbers. So 1 gallon is 16 cups and 365 days in a year. This time I have more room. I'm actually going to write it out. So this is 14 times 365, and the only word left is gallons. 16, and the only word left is years. That was multiply. And last step. Top divided by bottom, and I get about 319 gallons per year. Everyone get that too?
Yeah, it was like 319 and 3/8.
Yeah.
Yeah.
If you wanted to round to 320, I wouldn't mark that wrong. Do we really think Chuck is that consistent? Who knows? This is obviously fictional. We hope.
I don't know. Some of us drink a lot of coffee.
Yes.
Interestingly, this said 17 cups, or 14 cups, but it didn't say how many ounces were in the cup. I'm assuming it was 8 ounces. So I drink more than 14 cups because I'm drinking more than 8 ounces.
Ah. Yeah, this is a standard 8-ounce cup.
Cup right now, and I'm on like my 3rd one already just in class. So.
In Math 25, we do the problem of if you, instead of going to Dutch Brothers every morning for your coffee, put all that money in retirement, then how much would you have when you get to be 65? And everyone like screeches when we see the answer. Yes. Okay. Anyway, enough about our personal vices. So this one's kind of a middle problem. All we're doing is a divided by 16 and a times 365. Right? That's all we did. So the rest of it is just a lot of writing to make sure we did it right. And we didn't multiply by 16 accidentally. And we didn't divide by 365 accidentally. So If you are great at these measurement conversions, you don't have to write this much. But for almost everybody, we just don't do measurement conversions in real life that often. So it's nice to have a foolproof process, especially in an open notes test, that I can just do this process, I'll get the right answer, it tells me what to do, life is happy. Somebody might be wondering, will we have time? So let's go look at this. Your Math 20 overall test. Now this term, you don't have a time limit, but let's pretend it was a normal term and you did. So you would have a normal LCC final is 110 minutes and 35 problems. So 110 divided by 35, that's a little more than 3 minutes a problem. And some of these are very fast, right? When you're just doing Riplop and so on, that's a lot less than 3 minutes. But on average, you have about 3 minutes per problem. So if you can do this in maybe 4 or 5 minutes, that's still not too long, even on a timed test, which this term you don't have. So this isn't a bad system. This is also, by the way, most of intro chemistry. So if you've ever been scared of taking an intro chemistry class, this is pretty much what you do all term long, are these unit analysis problems. So, ta-da, you're ready for intro chemistry. Okay, we're almost done with our time, so let's go back and look at the actual lecture notes. So unit analysis is such a long process that, unlike usual, I've given you long step-by-step things. So we didn't do the ones in the lecture notes because they're all already written out step-by-step for you with lots of nice colors. So look at those after class sometime before you start your other homework. Then I give you some kind of easy things here and work your way up a little bit, but none of these are too bad. So these are good ones to practice. If anyone wants to send me an email and say, I need the answers to 86 to 90, then that's probably something I can do and give you the answers to click on. So one warning is that your answers might not match the back of the book. If you are going to practice in the green textbook or the online textbook, which I encourage you to do always, then we're rounding in the middle. Let's see, not in these, but in the ones where you're mixing standard and SI. The only one that's true is inches to centimeters. There's exactly 2.54 centimeters in an inch by definition. So the point of 91 and 92 is here's two different things you might see in a book or on the internet. A liter is 1.057 quarts, or a quart is 0.946 liters. Those are both things that to 3 decimal places are true, but they are both rounding slightly. And depending on which one you use, you will get a slightly different answer to the same problem. So the reason I point this out now is if you do some homework in your textbook and your answer is close but not the same, and you're mixing standard and SI, that probably means that they just used one conversion rate and you used the other one for whatever the problem is. It doesn't mean you did anything wrong at all. So when you see that, just pay attention. It's probably that you are correct and it's not a rounding thing. Lots of videos if you want to see other people do videos of these. And when I see you next time, we'll talk about polygons and we'll actually do some geometry that looks like geometry. Okay, any last questions in our final 2 minutes? None at all. I encourage you to get the easy check mark for tutoring if you haven't yet. If you go to the Math 20 tutor forum and ask Greg a question, then I'll give you a check mark. And you can email him if you don't want to have everyone see your name and know that Debbie asked this really easy question. Then she can just email him and say, I don't want to put my name on the forum. So can you do this easy one and both ask the question and answer it, and then you can be completely anonymous.
So I use Trio. Do I have to go to Greg and use
Nope.
him?
If you used Trio, then you already have the tutor check mark. This is just something that doesn't require any scheduling at all. The MRC has great tutoring. Trio has great tutoring, but to some extent online with distance learning, you have to make an appointment. The advantage to this is just you can send them a question. Please do this problem. And you don't have to actually schedule anything. So for some people, that's easier. But you're good. Okay, have a good couple days. I'll be back in a bit for people who want to do our Monday study session and just do lots of homework
yeah.
problems together or something. And if not, have a good day.
Thanks,
Thank
David.
you.
Thank you.